All right, so our next section is rational exponents and how they relate to radicals and what they all mean. So a rational exponent is an expression with rational exponents, means that the exponent is a fraction. And each part of the fraction means something different depending on where a number is located in either the numerator or the denominator. So we have two rules to rewrite them. So in exponential form, if it's a to the 1 over n power, this means it's the nth root of a. So a to the 1 over n power equals the nth root of a. So if it was like a to the 1/3, it's the cube root of a. Now, if you have a rational exponent where it's a to the m over n power, then the n, so the nth root of a, raised to the mth power of a. So what that means is that the numerator of the fraction becomes the exponent with the base, and then the denominator is the root in the radical sign. So if we had like a to the 5/7, the 5 becomes the exponent, so it's a to the 5th, and then the 7 becomes the root, so it's the 7th root of a to the 5th power. All right, so that's what those two things mean. So starting with our examples, we have x to the 1/4 power. So since it's 1 over 4, it is just the 4th root of x, and that's it. So this one, we have 15n to the 1/4. So since there are parentheses around the 15n, all of that goes underneath the radical sign. And then since it's 1/4, it is the 4th root. So number 3, we have 24 to the 1/3 power. So 1/3 is the cube root, so we have the cube root of 24. And we can simplify this because one of the factors of 24 has a cube root, and that's 8. So this becomes the cube root of 8 times the cube root of 3. So the cube root of 8 is 2. So we have 2 cube root of 3. And that is the cube root of 24 simplified. All right, so the next several, we're just going to rewrite in the correct form. So we have 7 to the 2/3 power. So the numerator, so the 2, becomes the exponent. So we have 7 squared. And then the 3 is the index. So we have the cube root of 7 squared. And that's probably about the best radical sign I've ever written in my life. So that's beautiful. So 7 squared is 49. So we are going to simplify that. So we have the cube root of 49. And then that is 7 to the 2/3 power. We can't simplify that further. 49 does not have any factors that have a cube root, so we're going to stop there. So for number 5, we have k to the 7/2 power. So 7 becomes the exponent. So we have k to the 7th power, and then 2 is the index. So we have the square root of k to the 7th, and we can simplify this. So a multiple of 2 that is close to 7 is 6. So we have k to the 6th power times k to the 1st. So then 6 divided by 2 is 3. So we have k cubed times the square root of k. And that's our final answer. All right, so for number 6, we have 3 to the 5/4 power. So 5 becomes the exponent. So we have 3 to the 5th power, and then the 4th root of that. So 3 to the 5th power is 243. Oops, I wrote the wrong thing there. So it's the 4th root, not the cube root. All right, so we have oh my gosh, I did it again. We have the 4th root of 243. I'm going to look at the factors here. because I'm pretty sure we can simplify this. Yes. So factors of 243 that have a fourth root are 3 and 81, because 81 has a fourth root. So this becomes the fourth root of 81 times the fourth root of 3. And the fourth root of 81 is 3, so we have 3 times the fourth root of 3 as our final answer. And there we go. All right, so for number 7, there's a slight difference. You notice there's parentheses around the AB, which means the 3 4s belongs to both the A and the B. So what we're going to do is we're going to make this AB cubed, because the numerator is the exponent, and then it's the fourth root of all of that. If we want, we could also write it as A cubed and B cubed separately underneath the radical sign. I will accept either because we couldn't simplify it any further, so we're good to leave it that way. All right, so we have negative 6x in parentheses, all to the 2/3 power. So we have negative 6x squared, and then the cube root of that. So the 2 is the exponent, 3 is the root. Now, for this one, we are going to square both of these. So negative 6 squared is 36. And then x to the second power is x squared. So we have the cube root of 36x squared. All right. 36 does not have any factors that have cube roots, so that's as simplified as it gets. All right, so now this, for number 9, it's slightly different because it's 7 times the quantity 12w to the 1/2 power. The 1/2 only goes to what's inside the parentheses. So the 7 is the coefficient outside of the radical sign. And since it's 1/2, it's just a square root. So we have the square root of 12w, which we know we can simplify the square root of 12. Okay? We know that it's the square root of 4 times the square root of 3. And I'm going to leave the w with the 3 because we know that doesn't go anywhere. So the square root of 4 is 2. 2 times 7 is 14. I'm just going to skip writing that step. So we have 14 times square root of 3w. And that's as simplified as that one gets. All right, moving on to 10. So now for these ones, we're starting with them in radical form, and we want to write them in exponential form. So we have the cube root of 16. So since it's just the cube root and there isn't an exponent in here, our exponent is 1/3. So this is 16 to the 1/3 power. And that is the final answer for that one. So for 11, we have the square root of xy. Because xy are two separate variables, but they're both underneath the radical, when we write them in exponential form, we're going to put parentheses around it because it's that entire quantity underneath the radical sign. Now, there isn't a given index, so we assume it's 2, which means this is 1/2. And there we go. So xy to the 1/2 power. All right, so we have the fourth root of 8w. So once again, like the xy, 8 and w are both underneath the radical sign, so they need to be in parentheses in our answer. So since it's fourth root, this is 1/4. And there's our answer. All right, so 13 through 15 are the same, except for now we have exponents underneath the radical signs. So now we have the cube root of 11 squared. So 11 is our base. Now remember, the exponent underneath the radical becomes the exponent, or the numerator and our exponent, and the root is the denominator. So this is 11 to the 2/3 power. And that's our final answer. I'll write this larger so the 2/3 looks better. There we go. So 2/3. All right, so 14, we have the 4th root of k to the 5th power. So we have k as our base. The exponent with the k becomes the numerator in our answer. And then the index is the denominator. So k to the 5/4 power. Voila. Now, for 15, we have the quantity of the square root of 3m to the 7th power. The square root is the fraction 1/2. So if we want, we can make this 3m to the 1/2, then all of that to the 7th power. So what we do is we multiply these two things together. So 7/1 times 1/2. So we have 3m, and then it's the 7/2 power. And there we go. And that's the final answer for that one. All right. So we have the 4th root of negative 2a, all raised to the 5th power. So we have negative 2a. The exponent is the numerator, so we have 5 over, and then the 4th root, and there we go. And that's as simplified as that one gets. All right, so for this next one, we have the square root of 10 to the 5th, a cubed, and b to the 1st power. So we have 10 to the 5th, a cubed, b to the 1st, all to the 1/2 power. And this is where we're going to use our rules of exponents, because when we are raising an exponent to an exponent, we multiply. So 5 times 1/2 is 10 to the 5/2 power times a, and then 3 times 1/2 is the 3/2 power, and then 1 times 1/2 is b to the 1/2. This one gets a little complicated because you have to pay attention to each individual exponent, but that is what this problem would look like written out in exponential form. And it's going to work similar in 18. So we have the cube root of 9x to the 7th, y to the 4th. So we're going to make this in each individual term. So we can, from here, we can do it a different way instead of making the cube root into a fraction. So this is 9 to the 1st power. So that 1 in the exponent is the numerator, and the root is the denominator, times x. And so 7 is its exponent, so it becomes its numerator. And then the root is 3, so that's the denominator, times y. And 4 is its exponent, so it's its numerator. And the root again is 3, so that's the denominator. So there are two ways to do those types of problems. And I don't care which way you do it, it works either way. All right, so to simplify expressions with rational exponents, you have to rewrite all radicals in exponential form, and then use exponent rules to simplify the expressions, and then write your answer in radical form in the simplest form. And if we need to, we may need to rationalize the denominator. All right, so we have x to the 1/3 times x to the 1/4. So when we are multiplying when we're multiplying two bases and they have different exponents, you add the exponents. So we're adding 1/3 plus 1/4. And this is where the fact that we're adding fractions is going to freak everybody out. So we need a common denominator with 3 and 4, which is 12. All right. So If 12 is our denominator, we multiplied 3 by 4. So we're going to multiply the 1 by 4, so we get 4 over 12. And then we multiplied this by 3. So if we add those, 4 plus 3 is 7, and the denominator does not change, so it's 12. So this becomes x to the 7/12 power, but we need to write our answer in radical form. So 7 is the exponent, so it's x to the 7th, and 12 is the index. So it's the 12th root of x to the 7th. And this is the final answer. All right, so for 20, we have 1/4, or x to the 1/4 times x to the 3/2. So once again, we're multiplying, so we add our exponents. So 1/2, or 1/4 plus 3/2. So our common denominator this time, luckily, is 4, so we only have to change this second fraction. So we have 1/4. And so we multiplied this by 2, so we're multiplying the 3 by 2, and we get 6. So 1 plus 6 is 7. Denominator stays 4. So we have x to the 7/4, which if we write in radical form, x to the 7th, because 7 is the exponent, and then we have the 4th root of that. Now, we can simplify this further, because we can make this the 4th root of x to the 4th times x cubed, and then 4 divided by 4 is 1, so you get x times the 4th root of x cubed. And this is the final answer of x to the 4th times x to the 3/2. All right, so for 21, we have m to the 5/2 divided by m to the 7/4. Now, we subtract the exponents if we are dividing. So we have 5/2 minus 7/4. And once again, we can make our common denominator 4, so the 7/4 stays. And we're multiplying this by 2. So we have 10/4. So 10 minus 7 is 3. So we have m to the 3/4, which in radical form, we have the 4th root of m cubed. I'm going to run out of space. And that is our final answer. All right. Now, we kind of talked about this a little bit earlier. So we have a to the 1/3, all of that raised to the 5/2 power. So if you have an exponent raised to an exponent, you multiply them. So when you multiply fractions, you just multiply the numerators, then multiply the denominators. So 1 times 5 is 5. 3 times 2 is 6. And then we're going to rewrite this in radical form. So 5 is the exponent, so a to the 5th power. And 6 is the index. And then that is the final answer. So we cannot simplify that any further. So we have 32 to the 1/2 to the 1/2 power. So 1 times 1 is 1. 2 times 2 is 4. So we have the 4th root of 32. Now, we can simplify this because we know that 16 has a 4th root, and 16 times 2 is 32. So we have the 4th root of 16 times the 4th root of 2. So the 4th root of 16 is 2, and then this doesn't simplify, so 2 times the 4th root of 2. And there we go. All right, so for 24, we have 8x squared to the 2/3 power. So let's write this and multiply. So 8 to the 1st power is 8 to the 2/3, because 1 times 2/3 is 2/3. Now we have x squared to the 2/3 power. So we're multiplying 2 times 2/3, which is x to the 4/3 power. Right? Now, to write this in radical form, because both of them have their denominator is 3. That means they're all under the cube root sign. So we have 8 squared and x to the 4th. Now 8 squared is 64. So we have the cube root of 64 x to the 4th power. And now this part, 64 has a cube root. It is a perfect cube, and its cube root is 4. But we're going to talk about this x to the 4th first. So we have the cube root of 64, and then x to the 4th we're going to split up into x cubed times x to the 1st power. So the cube root of 64 is 4, and then 3 divided by 3 is x, and then we're left with this x to the 1st power. So then you have the cube root of x. And that's really badly written. So the final answer for this one is 4x, and then the cube root of x. And there we go. All right, so for the last 3 examples, we have 100 to the negative 1/2 power. So remember, negatives in the exponent flip fractions. So we can think of this as 100 over 1, and then that negative sign flips this, so that's 1 over 100 to the 1/2 power. Which means we're taking the square root of the fraction of 1 over 100. And because 1 and 100 both have square roots, we're just going to do that. So the square root of 1 is 1. The square root of 100 is 10. And voila. We have 1/10. All right, so for 26, we have 112 over 7, all to the negative 1/2 power. So remember, the negative flips the fraction, so we have 7 over 112 to the 1/2 power, which means the square root, and we're going to do the square root of both of them. So we have the square root of 7 over the square root of 112. You can write it this way first and then break it up, but I'm just going to skip at this step and do this way. Now, we have to rationalize the denominator here, because remember, we can't leave the square root in the denominator. So we're going to multiply the square root of 112 over the square root of 112. So 7 times 112, is 784. So we have the square root of 784 over 112. Now, I'm pretty sure we can simplify square root of 784, but just give me a minute to find the factors. (784) has a square root itself of 28. So the square root of 784 is 28. So this equals 28 over 112, which is a fraction that will simplify to 1/4. So all of this work to get 1/4. And that's our final answer. All right, our last example, we have the cube root of v times the square root of v. Let's write them in exponential form. So we have v to the 1/3 times v to the 1/2. And now we have problems just like we had several examples ago where we're multiplying something with the same base. So we add their exponents. So we have 1/3 plus 1/2. So their common denominator is 6. So the 3 to get 6 is multiplied by 2. So this is 2. Multiplied this by 3. So we have 3/6. So 2 plus 3 is 5. This is 5/6. So we have v to the 5/6 power, which written in radical form is the 6th root of v to the 5th power. That is the final answer of the final example, and we are done with this section. So have a good day.